Alright, today we're going to look at adding and subtracting algebraic fractions, or what are also called rational expressions. So the big idea when adding or subtracting algebraic fractions is that, or any kind of fraction, is that we need the lowest common denominator. We need to be sure that when we're adding or subtracting fractions that they do have the same denominator before we can do anything. So we'll look at a couple examples. These all have denominators that are whole numbers. So this first one, we've got 3, which is the same as 3 over 1 plus x over 5. It's letter A. In order to add them, we need to make sure they have the same denominator. So we know that if we multiply 1 times 5, we can get a denominator of 5, so we also have to multiply the numerator by 5, which means we've got 15 over 5 plus x over 5, and we're left with x plus 15 over 5. Yeah, I'll also do B. So B, we've got 1, which is the same as 1 over 1 plus 3 over x. If we want a common denominator here, we'll need to multiply 1 by x to get the denominator of x. So we multiply the numerator by x as well, and we get x plus 3 over, start over. So we've got x over x plus 3 over x. There's this x plus 3 over x. Notice when we're adding fractions and we have a common denominator, we just leave the denominator as it is. Okay, letter C. Yeah, let's do letter F. That one looks a little bit different, and all of the answers are on the following page. So I'll do letter F. You can do the rest of the examples and then just check your answers in just a second. So we've got, for letter F, we have 2x plus 5 over 4 plus, minus x minus 1 over 6. Okay, so we need a common denominator here. 2x, or is it 2 plus 5? 2x plus 5 over 4x minus 1 over 6. So this is 2x plus 5. Okay, to get a common denominator, we want to make it as easy as possible on ourselves, and we want the lowest common denominator. If you're ever in doubt, you can always multiply by the denominator of the other fraction. So for example, here we can multiply by 6 over 6, here we can multiply by 4 over 4. But actually that's going to require more work than if we think about what the lowest common denominator is, and that's going to be 12. We know that 4 times 3 is 12, and we know that 6 times 2 is 12. But it's no problem if you just multiply by the denominator of the other one as well. So, okay, so we distribute our 3. And we've got 3 times 2x plus 5 minus, and we've got a coefficient of 2 times x minus 1. Anytime you're dealing with subtraction, it's really important that you keep your factors in brackets. And this is going to all be over 12 because we have a common denominator of 12. Okay, so we can distribute. We've got 6x plus 15. And we need to make sure this negative 2 goes to both terms, and then it is negative. So minus 2x plus 2 over 12. And we combine our like terms then, so we have 6x minus 2x gives us 4x, and 15 plus 2 gives us 17 over 12. And of course, anytime we're dealing with these algebraic fractions, we're always thinking, okay, is there anything I can do at this point to simplify? And notice that there's nothing we can factor out of 4x plus 12. And because there's a plus in between, we can't cancel anything. So this is as simplified as possible. So that's our solution. So again, I would look at the rest of the examples. So what is that? C, D, and E. And if you could check those with the answers on the next page. So I'd hit pause right now and then check them with the next answers. So these are the answers. Hopefully those went well. Please write down any questions you have as you're taking notes when you're watching these. So some more examples. Now in the denominator we have a binomial. So for letter A, we've got 1 over 1 plus 3 times x plus 2. And again, we want a common denominator before we add these. So we can multiply 1 by x plus 2 to get a common denominator of x plus 2. So we'll have to multiply both the numerator and the denominator by x plus 2. Okay, so then we have, when we combine our like terms, we have x plus 5 over x plus 2, and again we look and see, is there anything we can factor out so that we can simplify this algebraic fraction? And the reality is no, and we can't factor an x out because 5, we can't factor an x out of 5, we can't factor an x out of 2, so it's as simplified as it can possibly be. Remember, we cannot cancel when we're dealing with addition between our terms. Okay, one more example. Let's do letter D. So for letter D we have, yeah, letter D is good. We have 2x minus 1 over x plus 1 plus 3 over 1. So we want a common denominator. The easiest one is x plus 1. So we'll need to multiply 1 by x plus 1, which means we'll also need to multiply our numerator by x plus 1. So we've got 2x minus 1 plus 3x plus 3. And it's all over a common denominator of x plus 1. We can combine our like terms. So we have 5x plus 2 over x plus 1. Again, we look and see if there's anything we can factor out so that we're able to cancel, and there is not. So it's as simplified as it goes. So again, try the remainder of these examples, B, C, E, and F, and then check them with the answers on the next page. So hit pause, try those examples, and then check them. Here are the answers. Okay, one more example. We've got binomials in both of the denominators now. So in order to add these together, so we have x over x plus 5 plus x plus 3 over x minus 5. So first we want to get our common denominator. And like I said when we were doing the example with 4 and 6 in our denominator, you can always multiply by the denominator of the opposite fraction. So for example, in this one, we can multiply by x minus 5 over x minus 5. And here we can multiply by x plus 5 over x plus 5. And when we do so, we've got x minus 5 times x over the quantity x plus 5 times x minus 5 plus we've got x plus 3 times x plus 5 over x plus 5 times x minus 5. So now we have a common denominator of x plus 5 times x minus 5. And we can combine our two fractions into one. So we can distribute our x to get x squared minus 5x. And then we have plus from here, and when we distribute those binomials we get x squared plus 3x plus 5x plus 15. And this is all over our common denominator of x plus 5 times x minus 5, which when we distribute that we have x squared. Actually, we don't have to distribute it. It's a bit easier to deal with if we leave it factored. But the numerators we do have to distribute because we want to combine any like terms. The denominator you can leave as a factored expression. Okay. then let's see, what can we combine? We have a minus 5x and a plus 5x, so those are going to cancel. We have x squared plus x squared, so that's going to give us 2x squared. We have a 3x, and we have plus 15, and it's all over our denominator of x plus 5 times x minus 5. And again, we check to see if we can factor the above expression. Yay! Okay, and to do so, we have one of those kind of advanced factorization problems here. We can think, okay, we've got 2 times 5, that's our product, which is 30. Our sum is going to be the coefficient of 3x, or just 3. So in our head, we're thinking, are there any numbers that multiply to 30 but add to 3? And the reality is no. So this is as simplified as it gets. If you wanted, you could expand the denominator, but it's not necessary. So just to show you, we could have x squared minus 25 if you want, but again, either one is as simplified as it can go. Okay, several examples involving that. Let's look at letter A and letter B here. So for A, so again, we need a common denominator. We can multiply by the denominator of the other fraction. So here we can multiply by x minus 2 over x minus 2. Here we can multiply by 2x minus 5 over 2x minus 5. So we've got 3x times the quantity x minus 2 plus, we've got 2x plus 5 times 2x minus 5. And in our denominator, notice both denominators have 2x minus 5 times x minus 2. Okay. So then we can distribute our terms in the numerator and combine any like terms. So we have 3x squared minus 6x plus, here we have 4x squared plus 10x minus 25 over our denominator. And again, it's not necessary to distribute in your denominator. So we're combining our like terms. We have 3x squared plus 4x squared, so we have 7x squared. We have minus 6x. This 10x plus 10x minus 10x is going to cancel, so we have minus 6x. Oh, plus 4, yeah, and then minus 25. And it's all over 2x minus 5 and x minus 2. And again, we can think if we can combine any like terms. We've done that, and then we think, okay, is there anything that we can factor? And notice our product here is 7 times a negative 25, and pretty unlikely that we'll have a sum of negative 6. But so you can leave it like this, or you can distribute your terms in the denominator. Either way is fine. So you get 7x squared minus 6x minus 25 over 2x squared minus 5x minus 4x gives us minus 9x plus 10. So either one of these is good. And if you want to just check with the solutions on the next page, we can also I'll do one more. I'll do letter B, and then if you could do the rest of the examples and check them with the solutions. Right, so looking at letter B, we've got 1 over x minus 2 minus 1 over x minus 3. Okay, again, we need to get a common denominator, so we can multiply by the denominator of the other fraction. So we can multiply this one by x minus 3 over x minus 3, this one by x minus 2 over x minus 2, and we've got x minus 3 times 1 minus, and it's really important that we keep our second binomial in brackets so that we're able to distribute the minus to both of those. That minus comes from this subtraction. So we have minus x minus 2, and this is over our common denominator of x minus 3 times x minus 2. So when we simplify, we get x minus 3, and we're distributing this minus to both terms. So we have minus x and then plus 2. And notice that's going to cancel our x's, and negative 3 plus 2 gives us a negative 1. Okay, and that's it. There's nothing that we can cancel here, and we can leave the denominator factored, or we can multiply it out either way. So again, please try letters C and D on your own, and then check them with those solutions on the next page. So hit pause, try those, and then check them. Here are those solutions. And the last example we're going to look at is, okay, well, what if we have a fraction within a fraction? How do we deal with that? So we'll just have to focus on our numerator where we have this fraction within a fraction. We'll have to get a common denominator even just in our numerator. So if we're starting with this, in order to get a common denominator in our numerator, we'll need to multiply by x minus 2 over x minus 2. And we'll get x minus 3. Again, really important to keep our binomial that we're multiplying by in brackets, because that negative 3 is going to have to distribute to both of those terms. This is over the common denominator of x minus 2, and the whole thing is over x minus 3. Okay, if we're dividing by this x minus 3, it's the same as multiplying by 1 over x minus 3. So what we really have here is our numerator, which is all of this, times 1 over x minus 3. Okay, and we'll want to distribute our like terms. So we'll have x minus 3x plus 6 times 1 over x minus 2 times x minus 3. And when we simplify that, we get negative 2x plus 6 over x minus 2 times x minus 3. And we can factor out a negative 2, can't we? So if we look, we can factor a negative 2 out of the numerator. So we get negative 2 times x minus 3 over x minus 2 times x minus 3, which works out perfectly because then we're able to cancel our x minus 3's, and we're left with negative 2 over x minus 2. And that's our final answer. And that's it. So hope you have a wonderful evening. I'll see you next class ready to practice these ideas.